Hello. Here I have an old German Kienzle clock. The model number is 606C, made in the 1960, which was sold in a mantel clock by Schultz. It was actually given to me by a friend, and after I fixed it, I actually gave it back to him as a present. I only do this sort of work, as a challenge to have something to do when I'm feeling in the right mood. So I apologize from the start, as I do not have all the work filmed. Depending on my mood and if I remember the film, as sometimes I just do the work while I'm feeling good, and later I, say to myself I should have filmed the whole thing. Because of restrictions on filming, I find it hard to do the work, and this is probably one of the reasons why I don't film everything. It affects my work, as I cannot fully concentrate on the work that I'm doing. Therefore, I take the opportunity while I'm feeling good to actually do some work. So that's the reason. But I will try my hardest in the future to try filming more of the work. In this video, hopefully you will see at least some of the work. And here is a couple of photos from eBay of the same exact mantel clock, as I never took any photos of the actual clock while I had it. Very unfortunate, as now I do not have the clock anymore. After really thinking about it, I should have kept it for myself, really. Because it did take me a while to fix it, and I had to do a lot of things to it. The actual problem of the clock was mainly two things. The winding barrel bushes that supported the shaft was very worn. The constant lever throw on the arm that winds the barrel spring when the contacts energizes the solenoid. Over the years, it has worn out the bushes. Of course, the top bush was the most worn, as the counterweight on top of the barrel to create momentum causes more force on the bush. The second problem was made by the person, or butcher I should say, that tried fixing it without having a clue of what he was doing, obviously. The two pin stops for the jewel lever were bent, which in turn affected the timing of the escape wheel, which was stopping the balance wheels from full amplitude at different clock angles. When you have it at different angles, it will be better, or you turn it to another place and actually might stop. The main thing of any repair is taking great care not to cause damage by poking tools without care in the items you're supposed to fix. Anyway, not to bore you so much, here's the video.
Okay, so this is the face of the clock, and this was the thread for the nut that holds the dial. And as you can see, I grinded that about 1.5 mil down, because the thread on it was no good. Now I have machined this insert here. So as you can see, I stepped it in, okay, and that will clip there, and it doesn't move, and you can see there, so that fits inside. And then I will tap this to the right thread again. So that's the only way I could fix this. And I'll solder this around here, it won't come off. So I left a bit of the height there to act as a boss, as a guide, so I don't have to centralize this. If I grind it right off, then this would move. So can you see? Yeah, and there you can see it has been soldered, okay, all around. It's a matter of cleaning it up. Right size tap, right? It's a 9 mil by 0.75 millimeters, which I had to buy. Fine thread. Yeah. Just got the markings there. Can't even see. Somewhere there. Anyway, that's the size. Okay, so now it's been tapped, and there you go. So now that fits there. Because originally why the thread was stuffed, somebody have re-tapped it with the wrong size thread. So hopefully that should work. Okay, I'm gonna attempt to make a bush. I never done this before. 1 mil hole. Okay. By 2 mil bush for this gear, for that clock. So I have to make 1 mil by 2 mil. We'll see if I'm successful. Okay, that's the old bush. Which is 2.01 millimeters. Now I've machined 2.1 at the moment. The hard part is going to be breaking that off without that is still good. Okay, the one on the right obviously is the original bush. It's worn out. The one on the left is the one I did, and of course the hole is smaller, but I will press it in first into this, into the plate, which needs to go there, and then I'll drill it to the right size after. Alright, I'm going to attempt to press this thing in. I'm going to have to tap it. Let's see if it goes in. Let's see if the video can film this. Yep. If this can focus. No, it cannot. It can never focus this phone. There it is. Then it's a matter of drilling it at the right size. It's getting there. It's a bit tight. I just have to keep widening it. What I need is a set of broaches. You know, 0.8 mil to 1.2 or something. Okay, so since I've done the top plate, I changed one of the bushes here. I'm going to attempt changing this bottom bush. I think it's this one here. So it's about 1.6 outside diameter, and the inside diameter is 0.4 millimeters. So I need to make a new bush, right? There it is in the brass. So I'm gonna attempt to do it. I've got a a 0.4 drill here. Okay, let's see if we can zoom in. 0.4 drill bit. Okay, and we'll see if I can make a bush. All right, so starting off by facing off the brass here. Okay. See how we go. Keep in mind, this lathe here is not a it's not a clock or watchmaker's lathe, right? So I don't know how we're going to go with the vibration. I think I'm going to go a bit more speed. It's doing about 620 RPM. And it's drilling. The part I'm not going to know is if the 0.4 is going to be bigger than 0.4, because then I've done it for nothing. I think I want to go any more. So this has to be 1.6 mil. I'll keep cutting until I come close. Anyway, I'll pause it and then we'll see in the end. Okay, so that's the old bush. So that's a 0.4 mil drill, which you can see it fits quite loose in there. That's how worn it is. And as I have the good guess, by putting the vernier over it before I pull the bush out, I said it's 1.6, yeah? Well, guess what? Let's see what I'm doing here. It's exactly 1.6. So I can see just by having the vernier over it, I had a good assumption. Of course, with the lens, with the microscope, I looked at that. That is going to be 1.6. So here underneath the microscope, I'm showing the old bush, and that's the new bush that I pressed in. It sort of went in slightly a bit too tight, but I still got it in there, pressed it in, well, tapped it in. So that's the worn bush. Oops, it just ran off. And put that back there. That's on the other side. And you can see as well, I suppose it got enough, but that's where it's got the oil gallery there. So that's one side. And on the other side, we're over here. That's my new bush there. I'll probably have to run the drill a little bit just to create more of a hollow part for the oil. But not bad. Done it with just a small lathe. It's not a watchmaker's lathe or anything. And it's not easy to do. I mean, I had to use sandpaper, the file. So that's the gear there. Okay, and it's a very good fit. It's not as loose as how it used to be. Okay, so that's that. Let me put the bridge on. So probably I'm going to find it's still a bit too tight. Even the height might be a bit too tight, but that's okay. Just need some adjustments, and yeah, at the moment it's got too much pressure on the height. So yeah, I could see I'll probably have to press the bush a bit lower. Yeah, either the top one or the bottom one a bit more in. Yeah. Okay, so of the microscope here. By the way, this clock, which is a battery mechanical movement, is a Kienzle 606C from the 1950s and 60s. And you can see now it turns perfectly. No slack at all.
Okay, the top bush is changed and the bottom bush. So you can see here, before the old one I didn't show, but it had quite a lot of play on the in the hole there. So I probably left this bush a bit too high, but the oil will still get in there. Okay, you can see how smooth it is. It's got no oil and it's got no play at all. So once I put it back together, then I will oil it. Okay. And then I'll have to press this in. This was very hard to take off, by the way. I had to make another tool to remove this from the top there. And the gear that came off originally when I was trying to get it off, and I pressed it back in, and you can see it doesn't turn 100% through. It's got a slight twist. I'll see if I can straighten that, but I don't know if it's the shaft or the I'm pretty sure it's the brass gear, because it came off from the rivet when I was trying to get the spout off. Yeah, which was very hard to do. It was very tight in there, and I didn't know how it should come off. I didn't really know how they made it. That shaft looked like part of this. I didn't know it was a separate piece, even though underneath the microscope. But then I figured that's the only way it can come off, is to try to press it out. So I had to make a tool to fit under there, under here, so I can not put pressure on the whole thing, just only on this, and punch the pin out. Once I've realized that's how it had to come off. But very good, I'm happy.
Not finished. Just testing the clock. It's got a good sound. Can you see the switch? Push the spring. There you go. That's how it works. Here I cleaned the contacts. They were dirty. I've put a new resistor. The resistor is important because it goes across the contacts. Otherwise, if you don't put the resistor, the contacts will start arcing. So that's to stop the arc, because of the coil creates a spike, which is called back EMF, a reverse spike, which could cause a very small spark. You probably won't see it, but over the time, then the contacts will burn out. So you can see now, as soon as it touches, the solenoid pulls and it pushes the lever back and it winds the spring. There you go. You can hear it on the speaker here. That's the microphone here. That one. working pretty good. It's all clean. I took it all apart, re-oiled it. Only the oil where it needs it. You don't just put oil anywhere. Yeah. I always find things unbelievable, you know. That, right, is a square shaft, right? Cannot focus. Square shaft. Have a look at this. That, they butchered it. They closed the hole up. As you can see, it's not the right even size. It doesn't fit in there. They have it tight on the thread. It's been butchered, look. Right? I don't know what they done to it. They must have hammered it. So I cannot fit that in there anymore. Right? It spins in nothing, right? I'll have to file that now to get it back to the size of that. See that? It's almost hexagon they made it. Doesn't fit. It doesn't go in. It cannot go in. It's tight on the thread, so it just tells you how much smaller they made it. Unbelievable, man. Everything that I do, you know, it's always like that. That's what I always find. Other people's fuck-ups.
I got the clock on the timing machine now.
And on the software too. It's running pretty good. For a mechanical clock, that's pretty good. It gains a little bit, then it goes the other way, negative. But overall, it's keeping pretty good time. There's probably different pressures on the train. But it's pretty a straight line. So little very fine wave up and down, but overall, so it's 1600, actually no, 16,200 beats per hour. That's what this one clicks at. It's got a 1.6 millisecond beat error. That's between the clicks and the middle section of it. On the balance wheel, and the amplitude of the balance wheel is 254 degrees, 55 now. Now it's saying it's losing 3.7 seconds per day, but that you will see it constantly changes because overall it depends. It comes to a section where maybe it's got less friction or more friction. Remember, it's got that bush there. Those two bushes probably still a bit too tight. They got to bed in a bit more. You see now it's gone 0.6 now of a second a day. And there is 0.3, 0.4. I mean, I could adjust it again. See, now it's gone to positive. So it's no point, because it will be too hard to try to get it any more better than that. So this software I got, watch our scope.
That's all I have, so thank you for watching.